All right, this is our next video for geometry. Title of this video is Exploring Angle Pairs. We'll be looking at pairs of angles today, and we will start off with an introduction, a few definitions, and then do some solved examples. So as we go through these definitions, what I want you to try to do is maybe pause the video before each one, or at a minimum, think in your head about what these images might look like. So in other words, try to interpret the definition and create an image, create a drawing, a sketch on your own paper or in your mind about what these angles might look like. So the first one, adjacent angles, two angles that are non-overlapping and share a side. Adjacent means next to. So two angles that are non-overlapping and share a side. So I'll draw an example of two adjacent angles. And I will use just our brief number notation to highlight those. So angles 1 and angle 2 are adjacent angles. Okay. When we talk about non-overlapping angles, though, I want to be careful here and show you an example of angles that violate that rule and are therefore not adjacent. So we could think about this red angle, and then also we could think about this green angle. They share a side, but they're overlapping, and so that's what makes them non-adjacent, and that's why we need that non-overlapping criteria to be in the definition. Okay, so angles 1 and 2 are adjacent. Red and green are not adjacent in this picture. Vertical angles, I think, are the most poorly named angles pair in all of geometry. It has nothing to do with vertical versus horizontal. In fact, I don't quite know why they're called vertical angles, but two angles whose sides are opposite rays. So angle 1, let's say we have these three angles. Okay, angle 1 and angle 4 are a pair of vertical angles. And then also angles 2 and angle 3 are a pair of vertical angles. Very informally, students often call these opposite angles, but that has a slightly different meaning when we get into parallel lines, when we get into polygons. So please don't use the term opposite angles, use the term vertical angles. So just to be clear, red and green are vertical angles. The two green angles are vertical angles, and here the two red angles are vertical angles. It has nothing to do with vertical versus horizontal. Complementary angles are simply angles whose measures have a sum of 90. Frequently, you will see a picture like this, where we have maybe a 90-degree angle, and then we have a ray that creates two angles 1 and 2. So angles 1 and 2 are complementary angles. They don't have to be adjacent, though. So we could have here, this angle over here is 30, and this separate angle over here is 60, and those two angles would be complementary as well, so they don't have to be adjacent angles. Supplementary angles are simply angles who have a sum of 180, and so I will just very briefly sketch out, maybe this is a 125-degree angle, and then maybe we have a 55-degree angle, for example. Okay, so those two angles have a sum of 180 degrees, and so they're supplementary. A linear pair are angles that are adjacent and whose non-common sides are opposite rays. This is another good one to try to draw this one out on your own before I show you. Adjacent angles whose non-common sides are opposite rays. So let's draw some opposite rays first. Opposite rays are simply a line, right? And now we need to make sure we have a pair of adjacent angles. Okay, so angles 1 and 2 are adjacent angles. So in other words, the red angle and the green angle are adjacent angles, and the non-common sides in purple are the opposite rays. So that's called a linear pair. And lastly, an angle bisector is a ray that divides an angle into two congruent angles. And so if we have any arbitrary angle, this angle perhaps right here, we can throw in a ray that divides this angle into two congruent angles. And we'll denote those with the tick mark notation. And the angle bisector is this ray right here. So to be very precise, an angle bisector is a ray that divides an angle into two congruent angles. So let's do a little bit of true-false. Let's apply some of this with some examples and think about if it's true or false. So first, angles BFD and CFD are adjacent. So this is angle BFD, and then separately angle CFD. Well, those look to be overlapping, right? So they do share a common side, ray FD, but they are overlapping, so they are not adjacent, so this is false. Next, angles AFB, so let's draw that in, and EFD are vertical angles. That's true, okay, because their sides form opposite rays or their sides form lines. So this is a true statement. And next, angles AFE and BFC are complementary. Is that true? Yes, those do add up to 90. 62 plus 28 equals 90. So this is a true statement. Those are complementary angles. All right, making conclusions. Sometimes we need to be able to try to gain some information from a figure, and we need to be clear on what information you can assume is true from a figure and what information you can't assume is true. Okay, so in general, we can assume that if angles appear to be adjacent, they are adjacent. Okay, so we can assume, we can know that angles 2 and N1 are adjacent angles. Okay. So let's make a little list here. So we can assume that angles are adjacent. Next, we can assume if angles are that angles are adjacent and supplementary. So in other words, let's look at angles 4 and 5. Those do appear to be adjacent angles, and they do appear to be supplementary because it looks like they're a linear pair. Okay, so their non-common sides are on this line. Okay, so adjacent and supplementary, we can assume that to be the case as well. And lastly, we can assume if angles are vertical angles. Okay, if angles appear to be vertical angles, then we can assume they are, even if we're not explicitly told that. So angles 5 and 3, we can know that those are vertical angles. We can assume that. But what can we not conclude, okay? Or what can we not assume, okay? We can't assume the following. We can't assume that angles are congruent without being told specifically that they are. So in this case, we are being told that angles 1 and 2 are congruent. That's what those red arcs mean, okay? But we can't assume that angle 2 is congruent to angle 4 or something, okay? So we can't assume that angles are congruent. We can't assume that angles are right angles. Even if it looks like they're right angles, we can't assume that. And then we also can't assume that angles are complementary, unless we're specifically told what the measures of those angles are. Okay? So that's just a little bit about what we can and cannot assume when we're given a diagram. Let's look at this linear pair postulate next, and this will help us actually find some angles. So the linear pair postulate is just an assumption. Says that if two angles form a linear pair, then they are supplementary. So we can know that two angles are supplementary, that their measures add to 180 degrees if they form a linear pair. So we can apply that with this particular diagram here. We have a line KP, and then we have a linear pair, and the two angles are actually notated with algebraic expressions here. Our goal is to solve for x here, and in fact solve for the measures of those angles. So since we know that they're supplementary, we can see that from the diagram. We can say that 2x plus 24 plus 4x plus 36 equals 180. That's what supplementary means. We can then combine some like terms, the numbers and the x terms. We can get 6x plus 60 equals 180. Subtract 60 from both sides, 6x equals 120. And lastly, divide by 6, x equals 20. So that doesn't mean that's the measure of the angle. That means that's what x is equal to. So 2x plus 24 is 2 times 20 plus 24, which is 64 degrees. And 4x plus 36 is 4 times 20 plus 36, which is 116 degrees. Okay, so we're able to determine the measures of each of those angles. And let's see, our last example we'll do finding some missing angles based on the information given in a diagram. It looks like we want to find the measure of angle BAD. If I haven't mentioned this before, that little m out front means measure of. Okay, so that means that we're not trying to find where BAD is in the picture. We can see where it is in the picture. We're trying to find the measure of the angle in degrees. So that's just what that means. That implies that we're looking for a degree measurement. So we have some things that are notated here. We have an angle, it looks like we have two congruent angles, and we have one angle that is noted to be 58 degrees. So since the angles are congruent, we can say that this is 58 degrees as well. We're looking for the measure of angle BAD, which is this angle right here. And so it looks like it's going to be just double 58 degrees, which would be 116 degrees. All right, so it looks like we've answered that question. The measure of angle BAD is 116 degrees. So angle pairs, lots of sorts of angle pairs to keep in mind and memorize those definitions and what they mean. But we got through it, and that is a great place to stop.